Hey Earth Science folks, I'm here with Jordan here with Astronomy 6. It's our final lesson of the 2020 school year. So let's get started. We've got a lot to dig into. I'm going to start off by reading one of my favorite quotes or ideas about all of space, which is that the nitrogen that we find in our DNA, the calcium in our teeth, the iron in our blood, the carbon in our apple pies, and the plants in your room and in your body, all of these elements were made in the interiors of collapsing stars. We are made of star stuff. That was the astronomer Carl Sagan. I find it so wonderful to think about the idea that we came from stars. Everything in our world was created by these massive explosions. And so today's final lesson, we're going to talk a little bit about where did everything come from? How did we get here? What started everything? You might need your reference table at some point here. If you want to open it up and you have it at home, you're going to need to be on page 14 checking out the electromagnetic spectrum. All right, let's get started. First, we're going to start out just with our cosmic address. Where are we? Obviously, we are on Earth. And this is a true color image of the planet Earth. So Earth is a planet, and it is located in something called a solar system. So our solar system is the 8 planets that revolve around the sun, our star. So everything in our solar system orbits a star. Ours is the sun. This is obviously not the scale. All right. So planets are the smallest object. Then we move to a solar system. And then our solar system and sun is located into a much bigger thing called a galaxy. So a galaxy is a grouping of billions to trillions of stars, right? This is a picture, or not a picture, this is a drawing of our Milky Way galaxy. That is the name of our galaxy. There are billions of other galaxies in the universe, but this is ours. And we are located somewhere out here on one of the arms. This is called a spiral-shaped galaxy, and you can kind of see why it sort of looks like a spiral or of a shell, or maybe water going down a drain. Okay, galaxies can have other shapes. They can have elliptical or elong or irregular shapes, but ours, the Milky Way, is a spiral shape. And we're located out here. All this other stuff, these are other stars around which there could be planets, which means there's so many other planets out there. Here are some views of the Milky Way. If you get out into nature, far away from city lights, you can actually see this thick layer of stars, right? And why do we call it the Milky Way? Because when you're looking in the sky, it's like you're looking at the side edge of all these stars towards the center of the Milky Way galaxy. Here's a time lapse, right, showing the Milky Way. More amazing photography, right? Someone was able to line it up with Mount Fuji even. So pretty impressive. All right, here are some facts about galaxies. Small galaxies have a few billion, with a B, stars. Remember, billion is a huge number. Okay, a billion seconds takes 32 years to tick down. A million seconds only takes 11 and a half days. So when we talk about billions, we're talking about a gigantic number. All right, large galaxies have about 500 billion stars. The largest galaxies can contain up to 2 trillion stars. So often students will ask me, like, do you think, Jordan, do you believe in aliens? Do you think there's life out there? I think it's possible in the universe because there are so many stars, and around each star, you could have, 2 to 3 to 10 to more planets. It's possible there's another planet out there somewhere that has life. Now, do I want that life to find us? No, I don't, because if they can get to us and we can't get to them, that's bad news for us. All right. Our galaxy, the Milky Way galaxy, has about 300 billion stars in it. And there are at least 100 billion galaxies. In fact, scientists believe it's actually closer to 200 billion galaxies. So each of those has a billion stars. You get my drift. Space is gigantic. All right, and these galaxies form kind of a lacy pattern and can be clustered together. Our closest neighbor, galaxy-wise, is the Andromeda Galaxy. And like we've been talking about, we call this outer space. There's a lot of space in space. So this is a photo, and we're going to zoom in on where this arrow is, okay? And so what scientists did is they had the Hubble telescope floating out in space, and they zoomed in to a place that they thought was completely empty, right? And as they zoomed in, they said, oh, there's something here. Right? And they zoomed in a little bit further, and they saw this, right? All these dots represent different galaxies. And they zoomed in even further, and they saw this, right? So this was a place in space where they thought was completely empty, right? And as they zoomed in on this space, right now we're kind of zooming out from it, right? They could see there were thousands of galaxies in a place that we thought there was nothing. Right? So as we learn more and as we observe more about the universe, we're getting more and more of an idea of really how massive and gigantic the universe is. So when we say the universe, we are talking about the total of all the known and unknown objects and phenomena in space. The universe is everything, and the universe contains everything we can observe, and there's at least 100 billion galaxies. All right, this photo or this image is like the cosmic web. Each yellow dot that makes this lacy pattern is a galaxy, and the purple streams represent the dark matter, which is a very strange force that we're only just starting to try to explain. There's a good video at the end, but it's a lot of question marks about that. This image here, right, full of all this energy and of these galaxies, is only 0.0000001% of the entire known universe. All right, the universe is big. We are small. Just to give you a sense of the structure, from smallest to largest, planets are the smallest. Then we go to a solar system. Solar systems are inside galaxies, and then galaxies can be grouped together into what are called local groups, and in those groups get grouped together to make super clusters of galaxy, and these become totality of the entire universe. So universe is the biggest, planets are the smallest. So it goes planets, solar system, galaxies, universe. Now, how did the universe get here? All right, this is the image that's just kind of going back and forth. These are actual images from space that people have been able to mess around with a little bit and animate. So the idea behind the formation of the galaxy and of the entire universe, excuse me, is the Big Bang Theory. So the Big Bang Theory is the idea that 13.8 billion years ago, everything, all those galaxies, all those stars, everything that makes our entire universe was a single point, right? Everything was smushed down to this incomprehensibly small, incomprehensibly dense, incomprehensibly hot dot called the singularity. And that then we don't know what it was really like because our brains aren't made to think about it. But we know, or we think we know, that it started to expand, right? Like whoosh, spreading out every direction. Okay? Now, why do they think this happened? Obviously, it's 13.8 billion years ago. There were no stars. There was nothing. It was just all matter and energy collapsed together. So how do we know that this was there? Why are scientists so confident of this? Well, there's a couple of proofs. One proof is something called cosmic background radiation. So remember, radiation means heat. So CBR, cosmic background radiation, is leftover heat from the Big Bang. Think about this, right? You're making cookies in your house. You turn on the oven, you have it up at 350, right? You bake those cookies, you turn the oven off. Now, the oven is going to hold on to that heat for a while, right? You walk back into the kitchen or you can feel it throughout your house even after it's off. Well, the Big Bang was so hot, even though it happened 13.8 billion years ago, some of that heat is still left over, right? Scientifically, space should be zero or negative 460 degrees Fahrenheit. But space's actual temperature is negative 455 degrees. Where does that heat come from? It comes from the leftover heat from that 13.8 billion year ago singularity of everything smushed together, right? That was super hot. You've probably been on a really crowded train. Think about how hot a crowded train gets. Well, imagine if everything in the universe was crowded into one point. That's why all that heat that was, even though it's 13 billion years ago, almost 14, there's still heat left over because it was so hot. So that's one proof that scientists believe they have about the Big Bang. Okay? The other proof is something called redshift. So when scientists like Edwin Hubble looked at the light of distant stars and distant galaxies and measured that light, they noticed that things are all moving away from us, right? Every galaxy appears to be moving away from us. So if everything is moving away, right? Everything we look at, all the galaxies and stars are moving away from Earth. Then if we go rewind, if we press the rewind button on everything, what will that do? It'll bring everything back together, right? So because everything is moving away now, if we could go backwards in time space, we would see that everything started all together. So that's the second theory. Let's talk about redshift a little more, right? So this is just I think this is a good image, right? The Big Bang is everything together, and then it's always been expanding since then, like expanding out. And it's still expanding from that explosion. So redshift comes from something called the Doppler effect. The Doppler effect is when you push waves or pull waves. So wavelengths from objects that move away from somebody are being stretched, and waves from objects that are moving towards someone are pushed together. Now, with space, we're using light waves, but the way that most people experience this is with sound waves. So if you've ever been on the street and an ambulance is coming by, you will notice the sound of the ambulance will change as it passes you. Okay? So let's just review, right? Energy moves in waves. Visible light is what we see. The longest waves are on the right. So red has the longest wave. So anything that's moving away from us, the light of it is being stretched out. When you stretch out the wave, it moves more towards the red end of the spectrum. Okay? Here's the thing with sound, right? Did you hear that? Right? Did you hear how the sound appeared to go lower? They didn't change the siren. The siren is going the same. If you're sitting on the fire truck, the siren sounds the same the whole time. But to the observer, what's happening is the sound waves are being pressed together, so they're shortened. And then as the truck moves away from us, the sound waves are being stretched out, causing it to go down in pitch, right? Let's hear it one more time. Oh, let me go back. So that is a proof of the Doppler effect, right? The waves can get stretched out as they move away from you. So with pictures or with light, because it's like sound, it will be stretched. So when we look at certain elements, for example, the very simple element helium, it will create in a lab experiment, it will create these very specific lines, kind of like its signature that says this is helium gas. So this is where those would fall on the spectrum, these lines, okay? If something is moving away from us, that means the waves are being stretched out, which means they're moving more towards the red end of the spectrum. Really quick, right? Remember, red is the longest wave. So what happens to all the lights is at the bottom here. See how these two lines shifted to the right, towards the red end. These two lines move to the right. Everything from all the stars and galaxies that we look at, when we look at how their light should be in a lab and compare it with how the light appears to us when we look at it through a telescope, we noticed that every single thing is moving away from us, right? So if everything is moving away right now, then that means back in the past, 13.8 billion years ago at the Big Bang, everything started together, okay? So just if things were not moving anywhere, it would be stationary. If things are moving towards us, then they would get crunched together towards the blue end, which is the tighter waves. But everything in the universe is moving away from us, which means the whole thing is expanding, right? The wavelengths are stretched. Everything is moving away. The universe is expanding, but into what? Nobody knows, right? We don't know the end of the universe. We don't know where it ends or begins. In fact, there is no such thing because the universe is everything. So just because I've been saying it a lot, I want to just put it on writing. The universe is estimated to be approximately 13.8 billion years old, older than our solar system, older than our sun, older than our planet. How do we know how old it is? Well, we look for the oldest stars, and then we also can measure if we can measure how fast things are expanding, then we can use that same math to create formulas to go backwards and find out when things started. All right. How big is the universe? Well, the universe is 13.8 billion years old, which means light has been traveling for 13.8 billion years. So it's 13.8 billion light years across. 1 light year is 6 trillion miles, which means that the universe is about 82.8 trillion billion miles. That's what this number looks like. It's big. All right. Just get it through your heads. The universe is gigantic. It is old, and it started with the Big Bang, and we are lucky to be a part of it, and we come from these cosmic explosions. Now, are we at the center of our universe? No. right? In fact, the universe has no clear center. It's so massive, right? The universe would appear about the same no matter where you were in it. That's how big it is. So let's summarize everything. The universe is everything, the totality of all planets, galaxies, stars, all of it. The universe has billions of galaxies. Each of those galaxies has trillions of stars and an uncountable number of planets. The Milky Way is the name for our galaxy. The universe began, we believe, about 13.8 billion years ago with an event called the Big Bang. And the evidence that scientists point to for the Big Bang is the leftover heat or the cosmic background radiation that is detectable. So it's like that oven got turned on 13.8 billion years ago, a crazy heat. They turned it off, but there's still heat left over, right? We still have heat left from the Big Bang. And the other proof is the redshift of light from distant galaxies. All the light that we look at from all the galaxies is shifted towards that red end of the spectrum. That means all the waves are being stretched out. Why are they being stretched? Because they're moving away from us. So if everything is moving away, that means we could rewind time all the way back to when everything was together at the Big Bang. All right. So I got a couple more links if you want to check them out in the slides. A really great interactive solar system, a good video about dark energy, stuff about the Big Bang, and you can also explore our galaxy. I think this is a really excellent link. Don't forget to do your check for understanding. It's the last one. Oh, I should have changed it. It should say Astronomy 6. It's been a real pleasure teaching you guys. I hope you have a great summer. I hope you continue to look up and ask questions and take it easy. All right. Take a break. Bye bye, guys. We miss you.